Hi everyone, welcome to this channel, the Merchant Construct-preneurs and Tutors. So today we'll be looking at how to calculate the quantity of sand and cement for plastering of a wall. Now look at this picture here, this image here. You can see this is the man, the construction worker that is plastering the wall, and this is a brick wall. So he's plastering the wall. So we want to know the quantity of cement and sand mixture that will be able to cover a certain surface of a wall. Okay, without waiting for much of our time, let us understand what a plaster is and what makes up a plaster. So in this next slide, we have what is plastering. Now, plastering involves covering a wall or a ceiling with a layer of cement and sand mixture to achieve an aesthetically pleasing surface finish. What this whole thing is talking about, let's use these two images here. Now, this is a brick wall. Now, a plaster covers this brick wall so that to give us a smooth surface that is pleasing, aesthetically pleasing, like it is. At least the texture, looking at it, is smooth and everything is pleasing to the eye. I'm not seeing the brick wall with all the joints and with mortar and the rest. So a plaster actually covers the surface of a wall or a surface, whether a ceiling or a wall. So it covers it so that it gives you a uniform surface and it's pleasing. So it's a way of enhancing the splendor of your house, and also it can be done for interior or exterior walls, making it pleasing to the hand. So the it actually adds strength to the wall or ceiling, and then adds attractiveness to it. So that is a brief explanation of what a plaster is. So let's now look at what qualifies a plaster mix to be good, because not all plaster mix are good. Some people will just plaster and then once you go close to it, you scratch your finger against the wall, it starts peeling or it starts flicking. That is not the quality of a good plaster. So let's take it one after the other. Now, requirements of a good plaster. Now, a good plaster should adhere to the background, that's to the surface, and then should remain adhered during all climatic changes. Now, what this statement is saying is, once you plaster a wall, it should be able to stay there for all climatic changes, whether it's the rainy season, winter, dry season, whatever season it is, it should remain the way it is. It should not fall off, or it should not start giving signs of cracks when the climatic condition of a particular place changes. You get me? So that is very easy and explanatory. So if your plaster or your mix is not giving you that, then there's a problem. Now, the second one says it should be cheap and economical. Now, it should be cheap and economical. Okay, let me explain using this same. Okay, let me use this image. Now, looking at this, you can see this man is plastering, but then look at the heap of whatever it is, the mortar or the plaster on the floor. This is already what is name making this plastering work costly, because all this mortar, since they are still workable, they can still be reused instead of just abandoning it and then looking at this heap here, like just like abandoning it and then wasting it. No, it can still be reused. So one thing to preserve the plaster you are using is on this surface where he's standing, you can actually place a DPM material, there's a nylon, this thick nylon, to be able to, once it's plastering, the excessive plaster falls to the ground, so you can actually take them when it is still workable and then remix it and then use it to plaster the wall. So it actually makes it easier and cheaper. Hope you understand this. So let's move on to the next one. It should be hard and durable. Now, this is another quality of a good plaster. Now, let's use an example of you wanting to have your kitchen cabinet, or you want to have your TV console or your hanger on the wall. Now, some plastered wall, once you hit a nail to it, it gives way. Like, it is not strong enough to be able to hold anything that comes. Once you drill to hang your TV, is a problem. So a good plaster should be hard and durable. Should be able to withstand pressure. All these little things that we need to, I should be able to withstand it. So now the next one said it should be possible to apply it during all weather conditions. Now, whether it is rainy season or dry season. In the house, like in an enclosed area, you should be able to apply plaster. Not that rainy season you wait till everything is, you should be able to know how to control your mix so that you be able to apply your plaster during all conditions. The next one is should effectively check the entry or penetration of moisture from the surface. Now, some plasters, once you plaster the house, once there is moisture outside, it penetrates immediately through it. Like, will I say it is about the thickness now or the mix? You want to use a sand that is not good, that absorbs moisture. The plaster will not be, is not even stronger. The plaster will not be strong, and then the moisture will be able to penetrate through the wall. So a good plaster should have this quality to check against the entry or penetration of moisture through the surfaces. Now the last one say it should possess good workability. Yeah, good workability, like I explained in this image here. Once this thing is down here, you should not allow it to be dry before you start thinking of reusing it. It should be workable. Once you are applying, it should not be strong. Like, once you some people mix um plaster, like they mix in large quantities at once, and then once they are now applying it, before they get finished whatever they are doing, some of the ones that they mix is already hard, and then they know it will not be workable again. So what I advise is to be mixing it in batches, to be able to cover. If you are doing a particular wall, particular side of the wall, you should mix what should be able to do at least half of it. So once you know that as you are applying it, you are going to be able to finish that particular portion, not mixing a whole bulk batch of plaster and not be able to use it finish, and then the thing will not be workable again. You now start adding water, and then once you start adding water, then you're already changing the quality, you're already changing the properties of the plaster. The texture will not be the same, the color itself will not be the same, like the result you will get will not be the same. So these are the properties of a good plaster. You get? Okay, so now that we know the properties of a good plaster, so how do we now calculate what we want, like the quantities of the sand and cement that will be required for a particular surface area? So now the steps, we have these steps here. Number one step, say you determine the thickness of plaster. You're on site, you need to determine the thickness of a plaster, whether it's for external wall or for internal walls. Whatever purpose you want to use the building for, the wall for, you need to know. Start to now guide you in your thickness of the plaster, and also the mix ratio. Same thing, whether it's external or internal, whatever you want to achieve, you need to know what it is. Then the next one we talk about is the volume of plaster. Now we have the wet volume and the dry volume. Now the reason why we actually go by the dry volume is because of shrinkage. We need to account for shrinkage. Also, we need to account for material wastage. Just like this image here. We need to account for this material wastage. We should, by all means, make sure that we don't waste material just like this. Okay. So the next, let's calculate the volume of plaster required. The next one is to calculate the quantity of cement and sand. Now this is a mixture of cement and sand. As you can see, the sand and cement. So you now use it to get, using this formula, the cement ratio and the sum of the mix ratio times the dry volume. Sand, the same thing, sand ratio divided by the sum of the mix ratio multiplied by dry volume. So with this information, you'll be able to estimate the quantity of sand and cement that is required, right? Okay, so now let's go straight to an example, so I have a proper idea of what we have been talking about. Now given a wall surface of 10 square meter and plaster thickness for external wall of 20 millimeter, and then a cement sand mix ratio of 1:4, find the quantity of sand and cement for the plaster mix. Now I'm giving, okay, so as I was saying, now this is an example. We are assuming this, but on the site you are not, nobody's assuming for you. You are going to know the conditions and the use of the wall or the use of the property. That is what you determine whatever what's the name, whatever dimensions you're actually giving to these things. Now the surface area, let's assume this is the wall. So let's assume this wall, the area of this wall is 10 square meter. Now the 10 square meter we're looking at is, if we are looking at this, we are looking at two sides, because this is the front, this is the back. We are looking at this other portion too, front and back. You get? So let's say this is 3 square meters. 3 square meter at the front here, 3 square meter at the back here, or let's say 4 square meter. Okay, 4 square meter at the front here, 4 square meter at the back here. Then this, let's say this is 1 square meter at the front here, 1 square meter at the back here. So total of the whole area that we're going to plaster is 10 square meter. I'm just assuming that this, everything here is 10 square meter. We're doing the front, and then behind this short wall, behind this wall, and then behind this long wall too. Okay, so determine the thickness of the plaster. Now we are saying this thickness of the plaster will be 20 millimeter. Some use 25 millimeter, some use 15 millimeter, some use 30 millimeter. Like I said, depending on what you want to achieve and the purpose the wall is serving. Now the side, the mix ratio, the same thing. Now it's an external wall, so we are going for 1:4. Some can actually go for 1:5, some can actually go for 1:6, just depending on what you want to achieve with the wall. So the next thing is to calculate the volume of plaster required. Now for the wet volume, we have the area as 10 meter square, sorry, and then the thickness as 20 millimeters. So converting 20 millimeter to meters, we have 0.020 meters. So once we get our volume, wet volume as 0.2, now dry volume, because we are considering the what's the name, we are considering wastage and shrinkage, just as we stated here. We are adding 34% for the wet volume for shrinkage, and also 20% as wastage. So that is what is coming to give us 1.54. So once we multiply, this is dry volume, 0.308 meters square. So the next thing is to calculate the cement and sand quantities, right? Okay, now so the value of cement in the mix ratio is 1. The value of cement in the mix ratio is 4, because from our question we said it is 1:4. So cement to sand, cement has 1 in the ratio, 4 represents sand in the ratio, just as we have here, cement sand ratio. So now sum of the mix ratio, 1 plus 4 equals what? 5. Now for sand, let's go for sand first. Sand, the value is 4, sand ratio 4, sum of mix ratio is 5, multiply by dry volume. So once you multiply this, you have this value. Now we need to recall that the weight of sand per cubic meter is what? 1006 kilogram. Now so the weight of sand required will now be what? This multiplied by per, what's the name, per kilogram. Hope you understand this. We said weight of sand, you should recall that weight of sand per cubic meter is this. And now we have 0.2464 cubic meter. What is the weight of sand required? So once you multiply, this is the weight of sand required. Hope this is clear. Okay, now so let's move over to the next slide. Now we are now converting to tonnage. Most of these trucks, they deliver sands in tonnage and not in kilogram. So we are going to convert it to the industry standard, so that once you are buying, you're not telling them you want to buy sand in kilogram. They'll be looking at you, unless maybe you want to buy in bags. Really, all those ones too are not standard means of measurement on site, on large construction site. So now we should also recall that 1,000 kilograms is equal to 1 ton. Then 394.24 kilograms, how many tons will it give you? So once you do the mathematics, you have 0.394 ton of sand that is required for 10 square meter of plaster, of wall surface to be plastered. Now for the cement volume, you are using the same thing, say cement ratio over sum of mixed ratio. Now cement has a ratio of 1, and then sum of mixed ratio is 5 multiplied by the dry volume. So you have this value 0.0616 cubic meter. Now quantity of cement in bags. Now 1 bag of cement has a volume of 0.035 cubic meter, right? Then how many bags of cement will give you 0.0616 cubic meter? We do the mathematics also, cross multiply, and then you have 1.76 cubic meter. That is approximately 2 bags. Once you are buying and the cement is actually bagged 50 kg, like one bag. So 1.76, nobody is going to come to start measuring that for you. So this value I'm supposed to have erased, not supposed to be cubic meter, it's um supposed to be bags. Supposed to be bags. Okay, so I've corrected it here. So we have approximately 2 bags of cement. Now also recall that 1 bag of cement equals 50 kg, right? Now 2 bags of cement, how many kg? So once you multiply, now you now have 100 kg of cement. So you are buying 100 kg of cement or 2 bags of cement, as the case may be, right? Okay, so now results for a 10 cubic meter. Okay, results for a 10 cubic square meter of a wall with 20 millimeter thickness and a 1.1:4 cement sand mix ratio. We have cement required as 2 bags or 100 kg approximately, and then sand as 0.394 ton or 394.24 kilogram. I hope this is clear. So you can just go through this for any surface area you want to do. Just provide your thickness, assume your thickness, and then your mix ratio, and you are good to go. You're able to estimate what you need for plastering. Now, so this is like a table to just give you an idea of what and what. This changes actually whether you are having external wall 20, 15, 12. Some actually go higher depending on the country and what is obtainable there and the weather conditions. Then the mix ratio, here they are said external wall you are using 1.4 actually. Internal wall I can actually use 1.5, 1.4 or 1.5, 1.5. Ceiling I can use 1.3 or 1.4 depending on what I want to achieve. You get? So this is just like a table to guide you, but you need to stick to your local conditions, weather conditions, properties, and what the building is actually used for, the wall is actually meant to serve. So with this information, I believe you have been able to understand what is required of you when you want to calculate the quantity of materials, cement and sand, for plastering. Now, for more educative content on construction and structural engineering, you can actually subscribe to this channel, Merchant Construct-preneurs and Tutors, and hit the like button, subscribe and share to all your friends. Thank you.